9 minutes is not enough to explain what Voyager the 1st of May be experiencing right now, because the region it is traveling through is revealing something scientists could not directly observe before a spacecraft actually reached it. Voyager 1 has been traveling through space since 1977. It has survived decades of radiation, extreme cold, failing systems, and enormous distances. And today, it is more than 160 times farther from the Sun than Earth is. But the most interesting part isn't simply how far away Voyager is. It's what it is measuring. Recent research based on Voyager's observations is revealing that the space surrounding our solar system is not the calm, empty environment scientists once imagined. Instead, it appears to contain magnetic structures, pressure waves, plasma disturbances, turbulence, and enormous changes that can travel across billions of kilometers. And one of the strangest features is something researchers call the magnetic hump. To understand why this matters, we need to go back to the beginning. Voyager 1 launched from Cape Canaveral on September 5, 1977. Its original mission was never supposed to take it this far. Voyager was designed primarily to explore the outer planets, and it famously flew past Jupiter in 1979 and Saturn in 1980. After Saturn, however, Voyager continued outward. And it never stopped. For decades, it traveled through the outer solar system, gradually moving farther and farther from the Sun. Then came the moment that changed the mission forever. On August 25, 2012, Voyager 1 crossed the heliopause. The heliopause is the enormous boundary where the outward flow of solar wind finally gives way to the surrounding interstellar environment. Voyager had officially entered interstellar space. At that moment, it became the first human-made spacecraft to reach the space between the stars. But scientists soon discovered something unexpected. They had imagined that once Voyager crossed the heliopause, the spacecraft would eventually enter a relatively quiet region of pristine interstellar space. Instead, Voyager found structure. The region immediately outside our solar system was not simply empty space. It was being influenced by the Sun. The solar wind doesn't simply stop at the heliopause like a wave hitting a wall. Solar eruptions can send enormous pressure disturbances outward through the heliosphere. Eventually, some of those disturbances interact with the heliopause and propagate into the surrounding interstellar plasma. That means something that happens on the Sun can continue affecting space billions of kilometers away. And Voyager 1 has been watching those effects happen in real time. One of the most important discoveries came from Voyager's measurements of plasma. Scientists detected a persistent narrowband signal often described as an interstellar plasma hum. This wasn't simply a one-time burst. It allowed researchers to study changes in the density of the extremely thin plasma surrounding Voyager. And those measurements revealed something important. The interstellar medium isn't perfectly smooth. Its density changes. Its magnetic field changes. And the plasma contains fluctuations and turbulence. In other words, the space between the stars is far more dynamic than the simple picture of an empty cosmic vacuum suggests. Then Voyager encountered another major surprise. Scientists began identifying pressure fronts and shock-like disturbances moving through the interstellar environment. These structures were connected to solar activity that had happened years earlier. Think about what that means. A powerful event occurs on the Sun. The disturbance travels outward. Years later, after crossing an enormous region of space, Voyager detects its consequences. The Sun is still reaching Voyager even though the spacecraft is already far beyond the heliopause. And then came one of the strangest events of all. In 2020, when Voyager 1 was roughly 149 astronomical units from the Sun, its instruments detected a significant increase in magnetic field strength. The change happened relatively quickly. But the truly unusual part came afterward. Instead of immediately returning to its previous level, the magnetic field remained elevated. It continued changing over a prolonged period as Voyager moved farther outward. Researchers eventually referred to this extended structure as the magnetic hump. It wasn't simply a tiny fluctuation. It persisted while Voyager traveled through tens of billions of kilometers of space. And scientists had to figure out what could possibly create such a structure so far from the Sun. One explanation involves solar activity. The Sun goes through approximately 11-year cycles of changing activity. During active periods, solar eruptions and variations in solar wind pressure can launch disturbances outward. Those disturbances don't disappear immediately. They can travel through the heliosphere, interact with its outer boundary, and eventually influence the interstellar medium. According to modeling work, the magnetic hump Voyager observed may be connected to solar cycle-driven compression that propagated outward from the heliosphere. That would mean the Sun was effectively leaving a fingerprint on interstellar space more than 30 astronomical units beyond the location where Voyager crossed the heliopause. But the story gets even stranger. After the magnetic hump faded, Voyager entered a region where the magnetic field appeared unusually calm. The fluctuations became smoother. Some of the turbulent behavior seen earlier seemed to weaken dramatically. And this created a major scientific question. Did Voyager finally enter a genuinely different region of interstellar space? Or was the apparent calm simply the aftermath of the magnetic hump itself? That distinction is extremely important. If Voyager has actually entered a fundamentally different region, then scientists may have to reconsider how far the Sun's influence extends into the interstellar environment. The heliopause might not represent the end of the Sun's meaningful influence. Instead, the Sun could be shaping its surrounding interstellar environment much farther out than previously assumed. But there is another possibility. The calm region may simply be a temporary consequence of the magnetic hump. Imagine throwing a stone into a lake. The initial disturbance creates waves. Those waves travel outward. Eventually, there can be a region behind the strongest disturbance where the water appears unusually calm. That doesn't necessarily mean you've entered a different lake. It could simply mean you're observing the aftermath of the original disturbance. Something similar may be happening around Voyager. Researchers using sophisticated simulations have investigated whether solar-driven disturbances could naturally produce the magnetic structures Voyager observed. Some results suggest that they can.